Okay, so what I will be doing is a recap on the quantum mechanics exercises because I kind of forgot where we were. It would be great if one could open PDFs in Replit directly. Probably you can if you just open it from console, maybe. Can it be? Or from the shell? So what if I just say, can I just, is PDF a command at all? No. Can I just, command line, is there, it's just maybe with Firefox or something like that. Can I just, can I do Firefox, QM exercises PDF? Can I do that? I know this thing comes with at least Firefox. Go in the output or close these? To choose, okay. So, whatever. I have no idea. Oh, okay, so it's actually interesting. So it's installing it as I. That's cool. Should have used Chrome maybe. Could not find. How to install it? You can get. I can think. Whatever. That's not. That's just a warning. Just thinking. Because I could also just download the file. But it would be cool if I could just open it in here. No, we are. I was doing what I was doing. It's the table of contents. I was doing stuff from section 2. We were doing the normalization factor thing. We were doing the probability density. The probability density of finding the particle with momentum is isotropic, does not depend on the direction. So that's for sure what we're doing. I don't know. Twitter, no. What am I doing something wrong? Can I just stop that? Chroma thing. But what if I just do these? Will it install it? No. That actually works though, right? I mean, it actually opens Firefox, doesn't it? What the CPU of this thing? Good. Is it that I just can't? That's what I was missing. Yeah, okay, I was just missing the output window. So, no, that's definitely not how I would like to have it. Okay, so I was just missing these. If I, oh, I just call it, no, okay, so that's the, so if I open the, if I open, not in the console, shell, Firefox. Okay, there you go. So it actually works. Perfect. So we were, so no need to actually have it here open aside, that's good. We were doing, it still feels a bit clunky, but maybe there's a better way. I like that a lot as a workspace somehow, like even more than just like Jupyter notebooks, because it's like you literally can have the machine there for you. Anyway, where was I even? So I didn't even manage to solve this. I'm curious if ChatGPT would be able to solve the normalization factor n. Like if I give it like, probably it will not, but because if I give it the 2 1a, if I give it these I give it this and ask it like ChatGPT. So can I ask it to solve these? So what the following code output? Will it know? Okay, so what about I tell you that what I'm trying to do is I'm trying to solve the normalization factor of n. Let's see what happens. So n times, so minus alpha r a it's r, where I mean alpha is a real parameter. So where a is a real parameter and n is the normalization factor we're trying to find. In this case, the following steps to calculate normalization factor. Okay, so define the wave function as follows. Is that actually going to work? What the fuck? Okay. Thank you. Do we want to give it a try? Okay. I mean, wait a second. So, what have I done here? So so let's do the following. Let's try the following. Let's just say I want a new file, and we'll call it x2 1a AI. Okay, so just going to do these. I could also use Ghostwriter. I can try to use Ghostwriter later. So it's telling me to define psi like that. Sorry, guys. Then define the normalization condition. Then solve. I mean, this looks legit. This is definitely. Thank you. So, can I have another shell, or is it just opening the same one? because I'm having. Should have just run it as a background process. Because I have these here now. Well, the solution is this one, but I cannot. Well, let's just run it in main. Let's just well, obviously, I have to define all the stuff. So what is it? What is it that I'm? It's R. Should I define? I mean, it didn't tell me, right? But like how? Thanks. Let's be polite. How should I define th, ph, r, a in SymPy? Should remember, right? That's too generic, okay. And now it's kind of repeating the same thing. It's telling you real, true and positive true, which I don't think I can or I should. So I'm gonna just use the same definitions I have here. Well, actually they're all, yeah, actually why not? Maybe n is not, right? N is what we're trying to find. So let's just try. No, I mean n can definitely not be. N is just a generic symbol because we don't want to give it any specific constraints. Let's see what happens. Let's see what happens. Okay. Minus. Okay. The solution though is the square root of this alpha and pi. It's definitely giving me a different solution, right? I don't know if that's exactly what I was getting in here. First of all, let's check what has it. So, because I've been doing, I was doing this whole thing with the different spherical integration, and this guy is just like, boom. I couldn't even do that. I was having so many problems with these. So what is these even doing? So it's defining this stuff, and then it's saying the norm equals. So integrate. Is that correct? So because I was doing spherical integration, and this was giving me like if I write all this stuff. Ah, man. Keyword. If I write like these, well, at least it definitely gives me something that is closer, because, well, Gate gives me the correct solution. Did I? Don't remember, did I actually solve this? Or not? Oh, it's not exactly the correct solution, because this is the square root of this whole thing with alpha being, so there's an alpha to the power of 3 in here, and this is just the square root of, so actually it's missing something for sure. There's something missing because it's just like the square root of, you know, there's a square root of here, square root of here, so it's like the square root of, it's missing, let's say, a factor of 3. No, not a factor of 3, like a power of 3, because that's like alpha cube divided by pi, and everything like to the power of 1/2, and here is basically we're saying to the power of like 3/2. And now the question is, I don't know if that's just a typo or if it's just I'm missing something in terms of how the solution is prepared. But definitely, I think this has definitely maybe I didn't give it enough information, right? Because obviously you should be doing the spherical integration thing, because R is 3D space, and I think here it just treats R as a one-dimensional variable. But okay, it's not bad. It actually knows how to solve this stuff. Okay, so this was at least the state of this exercise, which was kind of not fully finished, but as close as I can get. And then we had exercise 2, 1b. What is this? So this is basically okay, I was trying to do, I think here I was trying to basically show that the probability density of finding the particle with momentum h bar k is isotropic. It does not depend on the direction of the momentum. And so to find the probability density of a particle with a given momentum, sort of my mental process was like, we need to transform that wave function into its momentum representation. That's kind of what led to all the how can we do this thing. And then basically do the square and then find the probability density that specific momentum. Okay, so that's, I think, then this is probably where I have to, what is x2 underscore 6? What's that? What is that? What is that? What is that? I don't know. Should I just delete that? There's definitely, or maybe it's exercise 2.6 maybe. No, this is what I'm trying to. It just goes pretty slow, the PDF thing. Problem. Oh, come on. Yeah, that's it. Consider free particle in one dimension. This is a wave function, so this is what I was trying to do. Okay, so that's the other exercise. But we're still in still in 2.1. So essentially, show that the spatial probability density is also isotropic. Calculate the expectation values. That's kind of the next thing to work on. But okay, so basically, at least this is what led to like the whole momentum thing with the a bit of the aha moment of like, hey, yeah, it actually turns out, right, that the wave function encodes both things, position and momentum information. It's just it's interesting because if you think about it, it's like it encodes both pieces of information, but it's written. It's kind of written in a way where you can write it in a way that is on, yeah, kind of like there are two different bases, I would say, right? So you're encoding it in a way because these two bases are related to each other. So you're encoding it in a way that it's basically showing you the position or the momentum. That's still, I have still some blanks in there in terms of, I don't know, feeling comfortable with that object, like the wave function as an object, right? But I would know how to solve this. Basically, you need to do the transformation. Show that the probability density is independent or of this specific momentum. So this is, I don't know what to do with this. Would I just then, I guess I would just replace it. I would do the integral to get to the momentum representation, then replace momentum for this. And then somehow try to see that it's isotropic so that it does not depend on the direction, the momentum. Okay. And then show a spatial probability density is also isotropic. So that's kind of the similar exercise, but just like with XT. Although how am I supposed to know T in this case? Because we're only given, that it's initially at T0 is like these, right? Wave function of a free particle. Yeah, okay, so you actually have to solve for sure. I mean, shouldn't there just be a generic formulation for that? Probably. But okay, so that's, yeah, we'll do that later today. See you later.